cross-validation. The only reason you would consider doing it is when your dataset is relatively small and you cannot afford to split it into three subsets, training, validation, and testing, because you want to maximize the number of observations you keep for training your model or you keep in your training set. Otherwise, doing the normal three subset split is easier to implement, it's more intuitive, and it's even faster for all the machine learning algorithms. So in the cross-validation, you would split your data into two subsets, one for training and one for testing, and of course you would maximize the number of points in the training subset, and within the training subsets you will do cross-validation to tune your hyperparameters, and we do this in three methods that we will discuss. So again, our problem starts when we are preparing for our analysis. So let's say we have a dataset that is labeled that we want to use to fit a classification model or any other type of machine learning model. So the first question that comes to mind, if I train my model with all these observations, how am I going to test its performance? So the logical answer is to take a small subset out to do the testing with. So I will train my model with this green subset, and I will test it on these yellow points that the model had not seen during the training phase. The second logical question, if I only have a training and a testing subset, how am I going to choose the best hyperparameter? And by hyperparameter we mean, for example, in K and N, is it K equal 1, is it K equal 2, is it K equal 10? Each one of those will have a different performance, but I can only test it with the testing subset once, so I don't overfit for that. So the logical answer is, let me take another small subset to utilize for validating or selecting the best hyperparameter I want to use for my model. But the problem comes when my dataset is small and I cannot afford to make three splits, because we all know when I increase or maximize the number of points I keep for my training dataset to train the model, I get a better performance. So here comes cross-validation. So cross-validation is when your dataset cannot be split into three subsets because you want to maximize the number of points in your training subsets. So you will only split into two, a training and a testing subset, and within the training somehow you will use it to select the best hyperparameters. So we have three methods to do this. The first method is the random subsampling. So first let me get rid of the yellow points, which are my testing dataset, so it doesn't confuse us. So if I have these green points for my training, I will select a random subsample from them. So let's say these purple points, and I will call these my validation data points or my validation subsets. So I will train my model with the green points and I will calculate its performance on these purple points. And I will say this is performance rate 1. I will take another subset of different purple points and I will train my model with the other green points and test it with these purple points this time. And I will calculate performance rate equal to. And I still did not change my hyperparameter. So if I'm using K and N and my K equal 1, I will calculate performance rate 1 for K equal 1. I will calculate performance rate 2 also for K equal 1. And I will do this X number of times until I get X fitted models that are being validated with different points every time and trained with different points every time. And I will take their average, and this is my average error rate or validation error rate for that hyperparameter. Then I will move to the next hyperparameter I'm testing for and calculate another validation error rate based on the average of the performance rate of all of these. And with this, I will be able to select the best hyperparameter that had given me the best average validation error rate for my data. Now to the second method, the k-fold cross-validation. So first I will get rid of my testing dataset, and instead of taking random subsamples from different locations, let me imagine I stacked my data from index 1 to index n. N is the number of points. And I started taking chunks of the data that are equal in size to use for validation. So in this, for example, first fold, my first 5 points are being used as my validation points, and my green points, the other green points, are being used to train the model. So I would train it with these points, then I will predict these points, and I will call this performance rate 1. Then I will do it to the second chunk. So basically I will train with all the green points, and notice the first green points are now, the first fold is now part of the training set, and I'm going to test it with this chunk, these purple points. And this is my second performance rate. And I'm going to do a third one. And I'm going to do this until I reach k-fits, which cover all my data. So basically, every single point has been one time in the validation set and many times in the training set. And I will calculate the average of all these performance rates and call this my validation error rate for this value of the hyperparameter. Of course, k doesn't have to be 10, for example, such as the one we have shown. It can be 5, it can be 6, it can be whatever we see applicable for our data. The value we're getting from doing a k-fold cross-validation as opposed to random sampling is that we are preserving the autocorrelation behavior in the data. So imagine we're talking about time series type of analysis. The data will depend on the location of where it is and what's before it and what's after it. So with the k-fold cross-validation, I'm keeping this shape. I'm not cutting it, somehow taking a point from here and taking a point from there, like the random subsampling. So this is the value I'm getting from the k-fold cross-validation. Now to the third method, the leave one out. So first let me get rid of my testing subset, which we have done in all the cross-validation method. And imagine in my k-fold, I go to the extreme, where my number of folds equal n, or equal the number of training observations I have. Then each fold will have a single point only. So if I do this, the first point, for example, this purple point will be my validation data, and all of these will be my training. So I will train my model with all these points and test its performance with predicting, for example, this purple point. Then I will do it for the second point, and again I will calculate a performance rate. Then I will do it with the third point and calculate a performance rate. And I will do this n number of times until I end up with n performance rates. I will take their average and I will calculate a validation error rate for that value of the hyperparameter. Then I will do it again for the second value of the hyperparameter, so I can choose the least or the smallest validation error rate and proceed to test it with the test data. Of course, the leave one out is the most unbiased cross-validation method because I'm testing the model with every single point. However, it is the most computationally expensive because imagine in a big data scenario where you have like 100,000 points, for example, to train, you will be fitting 100,000 models for every value of the hyperparameter. And then once you change your hyperparameter to test the other model, you will test for another 100,000 points. So this is very computationally expensive. The k-fold, on the other hand, is much easier and less expensive, but it could be biased. It could be that these chunks being chosen are not probably the best representation of the different behaviors we're getting. However, it saves us computationally. The random subsampling, on the other hand, it's very easy, very intuitive to implement, but it could be unlucky by choosing samples that do not represent the most confusion groups in your data or so on. So basically, these three methods, you have to choose whatever is logical to use with your specific data type. And each one has its pros and cons. But again, cross-validation should be your second option. Your first option should be doing the regular splitting, which is more intuitive, easier to implement, and it's even faster for the machine learning classification models that we have learned. But if your data set is too small, you might have to use cross-validation. We didn't cover how to do it in R because there is no direct way to do it in R. However, in most of these methods that we learned, the KNN and probably the SVM and many others, they have an argument called CV, cross-validation, where you would select the cross-validation method you want to use for your training your model. If you like this video, please hit the like button. It helps me a lot with the YouTube algorithm. Also, if you like content that helps you grow your skills in data analysis very fast, please hit the subscribe button. We have a lot of content coming up. Also, let me know in the comment if you prefer using the regular data splitting or the cross-validation. And within the cross-validation, what type of problems would utilize a k-fold, what type of problems would utilize a random subsampling, and what would utilize basically a leave one out algorithm. Thank you so much for watching the video, and good luck with your data analysis.